Welcome back. I'd like to go through the binomial theorem packet. We're going to go through all the examples. They're going to start out with some pretty easy ones, meaning you're just going to use the combination formula. Example 1, find the initial coefficient of the 7th term of a binomial raised to the 9th power. Well, many of you pull out Pascal's triangle, but I only have up to the 7th row. You'd have to add 2 more rows, and I could even make it like higher and higher. I could say initial coefficient of the 7th term of a binomial raised to the 12th power. So it's not always handy to use this, so it's nice to use the combination formula. You can use the combination formula. Whatever the power is goes on top. And if I want the 7th term, I always choose 1 less and make this a 6. So you could go to your calculator and just do 9C6, and when you do that, you get 84. You might be wondering why it is 1 less. Well, remember when you write the sigma notation, sigma starts with 0. So if you're starting with 0 at the bottom, 0, 1, 2, 3, 4, 5, 6, I already have 7 fingers up, so I'm at the 6th I value. So let's go to the next one. Find the initial coefficient of the 11th term of a binomial raised to the 10th power. So 10th power, that goes on top. Always the power goes on top. 1 less than 10 would, 1 less than 11 is 10. So if I did 10C10, many of you know there's only one way to choose 10 things out of 10. So that would be 1. Let's go to the next one. It says, what initial coefficient is this formula finding? So this is the power, which in this case is an 8. I know that's kind of small. Let me see if I can zoom in there. Yeah, I can see a little bit better there. So it's a binomial raised to the 8th power. And I am finding the 5th term. Because if I look here, that's a 4. 4 is 1 less than the number 5. So that's 1, 2, and 3. Make sure you have those down. Now we're going to go in, and we talked about the binomial theorem for positive integers. I have it written up there, the sum and how that works. What does it mean? Let's go through the pieces here. If I go through the pieces, we'll see that this right here, that part helps you figure out. Let me zoom out a little bit. The number of terms. This right here, the combination, gives you the initial coefficients for each term. This right here handles first term in binomial, and that makes it decrease the exponent. Oops, sliding off there. And then the other part right there, the B right there, handles the 2nd term in binomial. And you can see that the exponent will increase, or slide up, because it has an I, and I will go up and up and up. All I want to do for these next 4 is simply write the fancy sigma code. So let's get started. Sigma, what always goes on the bottom is an I equals 0. So if I was doing all of these, let me zoom out so you can see them all. If I was doing all of these, I would just make my sigma, put I equals 0 on all of them. And I'll put this one over here. On top is always the exponent. On your paper, you probably can see it a little easier. This one is a 6. So from 0 to 6, there will be 7 terms. This one will be a 3. From 0 to 3, there would be 4 terms when you expand. This one, 0 to 4, and this one, 0 to 5. That is always the same. Sigma, exponent on top, I equals 0 on the bottom. Next part is combination, which we don't write as C. There's just another funky way of doing this. You put the exponent at top and the I on the bottom. Exponent and the I. Exponent and the I, which will be forever changing. Exponent and the I on the bottom. Next thing you do is handle the first term. In this one, it's an A. It will always go to the exponent minus I power. So in this case, it's 6 minus I. In this case, it's an X, and it'll be 3 minus I. In this case, it's a 2x squared. Since that is more than just a single positive letter, I need to make sure I use parentheses, and it'll be 4 minus I. This one right here is square root of x, which I'm actually going to write as x to the 1/2 power. Square root is a half, and I'm going to raise that to the 5 minus I power. Next thing I'm going to do is handle the second term. That's the one that increases in exponents. In this case, it's a b, always to the I power. In this one, it's a y to the I power. In this case, it is a 3 to the I power, and this one, it is a negative 2y to the I power, which lets you know that it'll increase because it'll start with 0, then it'll be a 1, a 2, a 3, a 4, a 5. So we did examples 1 through 7 in this video.